Let's take some sample points. These points have two features, or you can say they are two-dimensional. We have chosen these points intentionally because they are easy to show in a video. Before we go any further, let's talk about the hyperparameters of DBSCAN, epsilon and mean samples. Epsilon is the maximum distance used to consider 2 points as neighbors. Mean samples is the minimum number of samples required inside the epsilon radius, including the point itself, for it to be considered a core point. Since these are hyperparameters, we have to experiment with them. In our case, we set epsilon to 1.5 and mean samples to 3. It's fine if you don't understand the hyperparameters yet. You will eventually understand it when we show you the algorithm. Let's start with the algorithm. The first step of the DBSCAN algorithm is to set all samples as noise. We have marked all samples in red. But before we proceed, let's create a legend so that we don't forget what each symbol means. In the second step of the algorithm, we find all the core points. We iterate through each sample. Let's consider the first point. Here, we have drawn a circle with an epsilon radius. That means the radius of this circle is 1.5, which we set as part of our hyperparameters. Now, within this circle, we have only 2 points, which is not sufficient since our mean samples is set to 3. Let's continue our search for core points. Now in this case, we have 4 points within the circle. That means this point is a core point, more specifically an unvisited core point. We continue applying the same principle to all the points and eventually identify all the core points. Now let's find the clusters. To do that, we start with any one of the core points. We mark this core point in blue, signifying that it is part of cluster 1. Then we perform a depth-first search. The next step is to process this core point. This point also becomes part of the cluster 1. Before we continue, I want to emphasize that a cluster can have multiple cores, and a core can expand an existing cluster. Please keep that in mind. Let's continue our depth-first search. Now we have stumbled upon a point connected to our first cluster, but it is not a core point. So we mark it as a border point of cluster 1. Similarly, we process the other 2 points. Remember, a border point can belong to only one cluster. Once it is assigned to a cluster, we cannot change it. Now that we have no more connected points for cluster 1, we start a new cluster with the next unvisited core point. Again, we follow the depth-first search and process the connected points. Finally, since we do not have any unvisited core points left, we can say that our algorithm is complete. That means this lonely point is a noise.